Hi guys, hope you are doing well. Today I'll give an overview about the data warehousing pipeline, more specifically the ETL process used in it. So in a data warehouse you typically store structured data like tables. This data is used for further analysis in machine learning models, data visualizations and business intelligence. But in order to process the raw data and combine it from all the sources and load it into the data warehouse, we need a set of steps. And it can be a very daunting process when handling very large amounts of data. So a straightforward pipeline to extract, transform and load big amounts of data to the warehouse is designed for this purpose. This pipeline is called the ETL data pipeline, where ETL stands for extract, transform, load respectively. So starting from the left, the data sources are pretty much raw data. They can be sales data, CRM data, ERP, third-party data and etc. And can be structured or unstructured. If the data is structured, it is usually loaded into a data warehouse at the end of the ETL process. Otherwise, if it is unstructured, it is loaded into a data lake. This source data can be historical data or streamed real-time as well. Once it is extracted, it is placed in a temporary data storage called a staging area. Here, the data is processed according to the requirements in the task. There are many ways to process the data, such as filtering, encrypting, auditing and performing mathematical operations on the data. So after the processing task is done, we move it from the staging area to the data warehouse or data lake. This represents the load phase in the ETL pipeline. So the data can be loaded fully at once or in incremental steps depending on the scale of the ETL architecture. After it is loaded, it can be used for data analysis and machine learning. Okay, so this is how the generic ETL pipeline works. I'll explain it in the context of a simple use case. We are planning to train a machine learning model to detect a binary classification between cats or dogs. And I asked ChatGPT what it thought about this scenario to generate an ETL pipeline. You can see its response is actually quite a good example. Let's make it into a diagram to see the data flow. So to train it, you will need datasets of cats and dogs images. First of it is not a real-time training task, so we don't need a real-time stream of data. A direct one of extraction and load of the data should do. So first we join multiple datasets of dogs and cats from different sources and transfer them to the staging area. Now let's say we have 10,000 images including video frames. We convert them to arrays of decimals or integers first, as the machine learning model only understands decimals and not the images directly. Now to transform it, we can follow the steps which ChatGPT gave for this use case. Resizing the images to a consistent size, normalizing the pixel values, splitting the data into training, validation, and test sets, and labeling the data with binary class labels such as cat or dog. Now after the data is processed, we load it in a format understandable by the machine learning model. So it could be a NumPy array or tensors depending on your model. We now have a preprocessed dataset to train our model on. That's how the ETL pipeline works for this simple use case. To create and maintain these data pipelines, specialized ETL tools are used. Some popular ETL tools are AB Initio, Talent and Informatica. Companies like Google, Microsoft, and IBM also use in-house ETL solutions such as Google Cloud Data Fusion, IBM DataStage and Microsoft SSIS. These tools have integrations with cloud tools like Amazon Web Services and Azure, and big data tools like Hadoop and Apache Spark. As big data and cloud tools are frequently used in conjunction with ETL tools in data pipelines. So that's about it for an overview of the ETL process and how it can be applied. Have a good day.